Welcome, everyone, to the second part of this month's Reintegrate Work Package 3 public webinar. The topic of today's webinar will be a presentation of an open source input data generation framework that is being used by large models, mostly energy systems models, but also other types of models like land use models with many regions and many data sources. I have been developing and using this framework for a few years now, and I am happy to share with you how it works, so you can get ideas of how tools like this can benefit your modeling tasks. So let me quickly share my screen. Can everyone see this in presentation mode?
Yes.
Yes.
Excellent. So yes, the topic is creating input datasets for models in general. Most of the things I will show are focusing on an energy system model, but it's not constrained to this model type. So the outline of today's presentation is that I will give the reasoning behind developing this idea, behind developing this framework, why it was chosen, and what is behind it. Then I will show the tools that this framework is using, and then I will move on to something more hands-on, which is how to see how a typical workflow on working with this looks like. And I will present two use cases very quickly. So one about, let's say, a new data source becomes available and I want to introduce it into the framework and the model eventually. And then I will show a highlight of the many aspects that this framework has in order to assist you with your modeling work, which is how to provide regional flexibility in your data. So the idea is it starts from Excel tables, basically, and the many problems associated with them, especially when models become larger, for example. But in principle, Excel tables are not so transparent. It's difficult to see changes between them in time. They are not easy to reproduce because you cannot easily track changes between them as time goes by, as opposed to what I will show later. They have the problem that they are error prone, as many of us know, because it's difficult to have a clear and transparent picture of what the content of each cell is, because some of them contain macros, some of them just contain numbers. They have a limitation in the size. They're not suitable for large data sets. And of course, as we know, Excel is a proprietary software, not quite compatible with the principles of open science. So the solution proposed is a framework called MADRAT. Stands for May All Data Be Reproducible and Transparent. Has been developed since many years, mostly at the Potsdam Institute for Climate Impact Research. It's on GitHub. It's open source, and any new developments and modifications are welcome by the developers. So essentially, the tools that are used to create an input data framework would be Madrat, which is what I just mentioned, is basically an R package written in the programming language R, and a second R package, and we will see why we have two, which is your package, a chosen by the modeling team or the modeler person. And this usually gets a name starting with MR, originating from Madrat, and then any name that you would want to give it. We chose, in my team, we chose the name MR-Prom because our model is called OpenProm. So how this thing works is that we have, or it has been observed, that when working with input data, there are typical steps in working with the data to prepare datasets for models that are being repeated for each dataset. So for each input data file, you might want to first look at the regional aggregation, if it's suitable, or you might want to correct some mistakes. You might want to, at some point, bring it to a format that is applicable to your model. So, and this, you have to do it over and over again for each new data source. So what the idea behind Madrat is that these steps can be automated. And additionally to this, it offers many other useful functionalities, such as it can perform quality checks. It can run tests each time you generate the datasets to identify errors or to make sure that the data is following some standards. It can it contains useful tools such as infilling functions. Versioning control is, of course, available since it is all managed in Git and GitHub, and it also provides versions to your datasets automatically so that you can distinguish datasets from another and keep track of changes between them. It also has functions for handling metadata. Many of you have heard the discussions about metadata that we've had with uploading Zenodo datasets from the Reintegrate project. So yeah, this is suitable also for this. Since it's a programming language, it's basically has limitations to the size of the data that it can handle that are close to what a computer can actually handle, which is a lot. And it's, of course, flexible and open source. So as I said before, the idea is to use Madrat, which is the engine. It's basically what provides all these tools for all these things, and then connect it to some code that you write, which is your package and would be called MR, your model. The combination of the two would create this input data framework. So how does this look like in a nutshell? As I said, it's an R-based data processing. It's an R-based data processing framework. It's open source. The main features are reproducibility, reusability, robustness, and transparency. So how does it look like in a very coarse presentation? It's that it contains pieces like these puzzle pieces that you see here, which are the ones I mentioned that are reproduced for every input data file that you may have, that can be glued together, they can be put together and create the input data framework. So first step would be to basically read in a data file that you have received in any form or that you have downloaded from a data provider from the internet. So you just basically what you want to do with this read source puzzle piece is to just read in the data just as it is. Afterwards, you can perform any calculations if necessary. You can also leave the data as it is if it suits you. You can perform calculations like filtering the data or merging data sets together in order to create new input data sets for your model. And then with a function that basically combines many of these last two, the read functions and the calc functions, you can create a whole data set, a bundle of data sets that is the input data set for your model. The idea behind the colors that we choose here, and it's explained here on the right, is that the puzzle pieces are what Madrat is providing. So they are called wrapper functions because basically they do always the same thing in terms of performing calculations and doing checks. And then users, modelers, are providing specific code to handle each form of data. We have so many different types of data. They can take many forms and have different levels of complexity. So this is how you deal with each specific data set specific to your modeling needs. And then in the end, you can combine, as I said, all these steps. This is here shown for one data set, let's say. You can connect these three. So the read functions, the calc functions, and then the retrieve function that runs the whole thing to create a data set, a very simple one, let's say. If you want to see how this works in a larger model, let's say, or in real life, as we can say, it's that these pieces that we saw before, so the yellowish colors are the read function. So we have different sources and different read functions for each source. It's basically the same type of function, but specific to each source. Then you combine them with calc functions, which are the ones that perform the calculations. And in some cases, a calc function can read in several sources, or a calc function can also load a different another calc function. An example for this would be that, for example, you have a data set that you want to disaggregate, like to calculate values for smaller sectors or for smaller regions. And you would need, for example, GTP data to do so. So you can have a function that loads the GTP data, calculates them for your chosen countries, and then use this as a weight in order to perform a disaggregation of another data set. Say, for example, a steel production data set or energy demand for smaller regions or for smaller countries. By the way, if this becomes a bit too complex, you can interrupt me at any stage and ask clarifying questions. We can keep it informal. It doesn't have to be monologue by me, this whole thing. So the idea is that, as I said, you combine these steps, this read and calculation steps. And here in the middle, you see this long bar, which is basically this retrieve function that you can run. And this will create a data set consisting of many data sources for a model that you are using. So how does this look like in practice? A typical workflow is that, as I said, you have this MR-PROM. In our case, our package contains code in order to process files located in a local directory on your computer. So this is where you store the data in order for the framework to access it, as you would do with the Excel files, for example, for your model. But it can also contain other useful files and folders, such as cache files. So the idea behind these cache files is that the cache files, they are there in order for you, if you have an intensive data set, like which needs many resources and takes a lot of time in order to be generated, Madrat can automatically identify steps that are kept constant, that have not had any change since the last time you run it. So it will, instead of running it again, load it from the cache. It's quite useful. And then there is also folders that contain the output. So the actual product of the input data framework, which is the dataset that you will load into your model, which can take any form. You can extract datasets in any form that you need. So we talked about the cache, and we talked about how the whole framework is structured in 3 steps, more or less. So this read part, this calculation part, and then this bundling part. Yes, sorry, this is the form of what I just mentioned. So you have this folder structure where you have these sources, is where you just list all your data providers, and inside each folder you can have the raw data that you receive from the data providers in any type of file type, because it's essentially a programming language, so it can deal with any type of files. So a bit more into detail in examples of how these steps look like. So we mentioned the read function. This is the very first step. The idea is that we write functions that have these standard names. They start with the word read, and then they have a data provider. For example, IAA, Enter Data, Navigate is a project. The IRF is the International Road Foundation, if I recall correctly. So these data sources give us data, we store them in the local folders, and then we write code that loads these into Madrat. The idea in loading this data is that they have to be identical to the raw data. We don't perform any changes here. If at all, we will only perform any corrections if they are absolutely needed. The idea behind specifying a subtype, as mentioned here, is if you have a very big data set, a very large one that takes a long time to load, you can filter it on the spot by loading a subgroup of this data by using a subtype. Then comes an intermediate step, which is a convert step, comes between the read step and the calc step. And basically, it is optional, but it's also very useful, and I will explain why. It's because a converted data set, so after reading it, will have to follow some standards. And the main standard is that you will need to have data for all 249 ISO countries from the official United Nations countries list. Why is that the case? This is the case if you have global models or regional models, you will need a data set that has values for as many countries as possible. So the fact that you need values for these countries doesn't mean that you have to provide values. You can also use the typical NA, which stands for not available. So the idea is that the data set has to have this complete picture, but it's not necessary to have the values. If you know that you only need values for one country, you can have one country and the rest of them are empty, but the dataset has to have this form so that it can be automatically used in calculations afterwards. There are tools such as this tool country fill that can automatically fill the values for the other countries with any value that you're choosing. It can also be a function that fills data with given with some rules that you want to be followed. The next step would be to have calculation functions. Now the calculation functions, as I showed before, they combine data sets, they do calculations, so they are specific to your modeling needs. So on the left side of the screen, we have the data providers. On the right side of the screen, we have your model. Your model might need data for fuel consumption, might need data for fuel prices, might need data for environmental policies, might need data. This stands for installed capacities in the past. What you want to do is to write functions that will perform any necessary calculations given all these data sets that you have available from here, and then give these data sets to your model. These calc functions actually create the data sets for your model. So the last step is this retrieve data. It's just a function that bundles all the necessary calc functions in order to provide one single data set that will be used in your model. The idea behind this is that by providing one output, one complete data set, is that you can have this whole workflow run each time the same. Also, in 10 years from now, you can run it and it will do exactly the same, which makes your data sets complete and reproducible and transparent. I hope this was not too quick. And indeed, there's even more detail, but I'm not going to go through it now because it might get too complex. I just want to highlight the step of regional flexibility. Now we'll run through the slides to go there. Essentially, it looks like this. I can take an example from here. So what you see here in the middle is a overview of how a dataset once loaded in the framework looks like. So you have these regions, and here it shows that there are 181 regions. You have the times, the temporal resolution, which is that there are 32 time steps, and then the data themselves, the types of units that you have in your data set. So the data provider gives us data for 181 countries. The idea behind the step convert that I mentioned before is that this data set is converted to a data set that has data for 249 countries, which is the standard, even if the rest of them are just empty. The idea is to have exactly the same data set, but this time for 249 countries. Now, what you can do is, since it's probably very unusual that you have a model that can perform an energy systems analysis or any type of analysis for 249 countries, usually you bundle countries together to create regions, or maybe even have a global model. So the idea behind using frameworks like this, so sophisticated and a bit complex, is to be able to easily perform aggregations and disaggregations of the datasets given some rules in order to transform a dataset from this regional aggregation to any other regional aggregation. And the way to do this is that you provide essentially a mapping such as this one, the one on the left, which basically is just a table that contains all 249 countries, their country code, and assigns them to region codes. For example, LAM stands for Latin America. OAS stands for Other Asia, but there are also countries, SSA, Sub-Saharan Africa. But there's also countries that you assign them to themselves because you want to model them explicitly. So your model might have 30 or 40 regions. Some of them are complete countries, some of them are aggregations of countries. Like here, for example, with Austria. Austria is in our model modeled explicitly. The rest of the ones on the screen, maybe also Belgium, I see, they are bundled together with other countries. So the idea is that with MADRAT and MRPROM, you can do this regional aggregation with just pressing a button. You don't have to have, whenever you want to change this aggregation, you don't have to perform any difficult task. You just provide a mapping like this, and the dataset will be automatically delivered in this aggregation that you are requesting. Yes, I think I will stop here. I think I have given you the main idea behind the tools that we developed and the reason why we did it. And the rest, I'm happy to answer any questions you might have now or at any stage later. That's it from me. Thank you. Yes, I have a question by Juha.
Hello. So this looks very interesting. I mean, with the Spine Toolbox, we are doing similar things, reading inputs and processing them. And it also gives you a little bit of a graphical interface to all of that. And we have been actually now building also this kind of aggregating data pipelines. They are for Europe at this stage, but it's been built in a generic way, so they could be replicated also elsewhere. So maybe I can put a link to that into the chat, and maybe also could be something if people are interested. I could also show about those at some point.
Yes, pity that we didn't know, because we would have included this as well in today's workshop. Thanks, Juha. I had Bruno next.
Yeah, quick. You actually use it yourself?
Yes.
Okay.
Yes. Yeah, my team and I, we use it, but there is also
Okay.
other modeling teams that have been using it for years now. Yes.
Yeah, I mean, you guys from Europe have nice organized data, but our data from one year to the next looks completely different. One year you might get a CSV file, one year you might have to extract it from a report using like table reading stuff or website.
But this is exactly.
And the code, I don't know, like every data point needs like bespoke code, and like
the idea behind this is exactly to provide tools that can help you correct these data sets, like make them nicer, correct mistakes. And so assuming you have a source that is breaking from year to year or even changing the format, the idea is that instead of doing this over and over again by hand, you write the code that does this correction step.
Yeah, but you can't write the code, because the code will work one year, but the next year it won't work because it's changed. The shape has changed.
Doesn't matter.
So you have to rewrite new code now.
Well,
and then the next year you have to rewrite the new code again.
But the power of writing code is,
and then you look for the
immense.
other data point, and it's different code. I'm just kind of like struggling, and then the aggregation tool is cool, but you can easily do that with in a pivot table in Excel. I'm just sorry, maybe I'm stuck with Excel, but
there's always a trade-off between investing into a tool like this and having a bit of a hard time in the beginning, but afterwards it's very rewarding. I can assure you about that. I wish I had more time to go into specific examples of ugly data sets and how to correct them. Maybe this could be the topic of a future webinar, because we've also had this, of course. And also another important point is huge complexity. Some data sets are hugely complex, and you just want to extract very specific information out of them.
Yeah, I know, but you have to write bespoke codes once off for that particular case.
Yeah, it depends on the use case. Sometimes data providers, they do minimal changes in every time they
if you get
publish
it,
a new
then
data
that's
set.
fine. Then you can reuse your code. But the problem is when it's changing so much that you have to rewrite the code, and then you can't find your code. You have to look for it, and you have to change.
Oh, your code is there. Your code is there.
Okay.
It's on Git. It's on Git and GitHub, and you see its story from the beginning, from 0 till today, and you can go back in time.
I think that this kind of thing needs to be built quite modular, so you don't need to rewrite everything. You're just rewriting the part that reads the input data to the first format from which the processing continues, and then you don't need to rewrite that continuation part. And I mean, in Toolbox, we can even do that importing part, usually using graphical interface pretty easily without code. However, of course, sometimes you have data sources that are not amenable to that, but all tabular data, basically, we can take in easily. And you can change that quite fast, the way you read that data, even if the data format changes.
Yes. Thanks both. Is there any other question, any clarification needed? Yes, Francesco has had to leave, but he asked whether we can try the workflow. Yes, for sure. I can also do a hands-on presentation. Absolutely. Yes, we can also do a test run with a data set, a toy data set or an actual data set, for sure. Yes, we can arrange that. Good. I would like to thank everyone for joining. and listening. Stay tuned for the future monthly webinars of Reintegrate, and I'm wishing everyone a lovely afternoon.
Thanks. Bye.
Thank you, Arsos. Thank you. Bye.
Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.